Yeah, hi. My name is Vimal. So today in this video, I had done my assignment from the course one, Machine Learning Foundations for Product Managers. So let us see. So you can see the CRISP cross-industry standard process for data mining. So we have followed this process model for building the machine learning model. So we have six sequential phases, and let us see one by one for the problem statement. So the first one is the business understanding. So here the problem statement is in this project we'll be building a model to predict an electrical energy output from a combined cycle power plant, which will be using the combination of gas turbine, steam turbine, and heat recovery steam generators to produce the power. So the data set what we have is we have total of 9,568 hourly average ambient environmental readings from the sensors from the power plant, and we will be using this particular data set to build our model. And so this is what the business understanding. So finally we are going to predict the net hourly electrical energy output. So this is our target variable which we are trying to predict. The next one is the data understanding. So if you see this is the data which is actually shared to us. So we have the first for 180 VT, V, VAP and average. These are all the features, and P, this is nothing but the target. So first four features are called as independent variable, and this is the electrical energy output. P is nothing but the dependent variable which we need to predict it. So, so in the data set we had total of 9,568 readings, and from the data we could see these for all the independent variables, and this is the dependent variable. And the applicable machine learning which we need to use is the supervised learning, and because we have the data which is already labeled, and the algorithm which is applicable is regression, because all the x and y variables are linear in nature, which are also continuous in nature. So also we have more than one x variable, so complex linear regression is the algorithm which is actually we need to apply here, and the corresponding error metrics for the measure performance of the model which we need to use here is regression error metrics. And under this you can see mean square error, mean absolute error, mean absolute percentage error, and r square. These are the four performance metrics which we are going to use it. And for example, to find the predicted target variable, this is the formula. Why, as we have four input variables, the formula could be m0 plus m1 into x1 plus m2 into x2 plus m3 into x3 plus m4 into x4. So y is a target variable where m0 is a y-intercept, and m1 to m4 is the slope of the x1 to x4, and x1 x2 x4 is nothing but the features. In the data preparation, so our assignment what it says, we need to follow some approach to build a model and to test it. So currently I had considered an approach where we will be using the same algorithm with two different approaches. So first algorithm I'll be using first approaches we'll be using the same regression complex linear regression algorithm with four features, and we'll be predicting the target y. And the next approach we'll be removing one feature which is having the least coefficient, and the remaining three features will be taking up, and we'll be using the same algorithm to build the model. So so the dataset will be as per the requirement. The dataset should be divided into 80% for training set and remaining 20% test for the test set for the model evaluation. So these are the two approaches which I told you. So for the both approaches, once the model is built, we will be using the remaining 20% test data to evaluate the performance of the model, and we'll be calculating the error matrix finally to identify which is the best approach to consider. I mean, which is the best model which is giving us the maximum output. I mean, the predicted variable should be as much as close to the actual variable. So the total observation is 9568, and the 80% data from the 9568 is 7654, and the 20% data is 1914. So the next modeling approach one, if you see here I would have taken the 80% data set from here. So we will be having only 7654 readings from the starting one to the 7654. And here this regression statistics I had calculated with the help of Excel form inbuilt formula, which is actually used for regression. So from the summary output, we could see here is the regression coefficients for intercept AT, V, AP, and H. Out of these, if you see now, AT ambient temperature, which is actually minus 1.99, so this is the least coefficient. So in the next modeling approach, I'll be removing this coefficient and I'll be calculating the same coefficients here. So the next one, if we see here, I had removed the AT ambient temperature, and I had again calculated the regression statistics here. Finally, you could see the coefficients for this particular three features. Considering the three features, these are all the coefficients value. And again, we are using the same 80% data set here for the same data set what we used in the previous approach one. Then if you see the evaluation approach for the first approach means, so you could see here the lots of data. So I had calculated finally, these are all the calculations which I did internally with the help of the formula from the for the MSE, MAE and MAPE for the R square. Finally, we are getting R square as 0.94, and if you see here the 20% data set which is not actually trained in the modeling, so I had used the remaining 20% set as a test set, and this is the predicted output values for the approach one. And the next sheet you can see here is I had used the second approach and I had calculated the R square value on the other MSE, MA and MAP. The R square here contributes as 0.808. Here also the remaining 20% test data is used as an input to predict the values of MAE, MSE and MAPE and R square. So finally, as a result, if you see now from the both approaches, the R square value, this seems to be 0.94 and this is 0.808. So finally, to conclude a model, we should consider the R square value. General assumption is it should be close to 1.0. So if we see the both approaches, R square for the approach one, it's almost 0.94, which is close to 1 when comparing to the second approach. So finally, the approach one is the best model to predict the target in the variable, which is nothing but the independent variable. Thank you.